Hello everyone, this is Amritpal Singh. Welcome to the next video. In the previous video, I've explained what is RDD, how we can create, how we can make use of transformations and actions in PySpark. In this video, I'm going to talk about very important topic of PySpark, which sometimes got overlooked. It is cache and persist. There are two methods available in PySpark which can improve our performance. Right? Let's get started. So when we work with RDD in Apache Spark or PySpark, we often perform a series of transformations and then run actions. We already have seen this in the previous video as well. Like we have some transformations with the likes of flat map, filter, and we have some actions available: collect, take, top, reduce, right? So we perform these operations. By default, Spark does not remember any previous results, but it means every time you call an action, it recomputes the entire transformation pipeline, which can be slow, obviously. Like in a simple word count, we have applied flat map, reduce by key, but in a regular or a real-time scenario, we can have multiple transformations, right? And when you call an action, the Spark as it indicates that it doesn't remember any results, so it has to recompute everything from a scratch, which is a time-consuming task or which is a slower task. To overcome this problem, we have the two methods available: cache and persist. Cache, it stores the data in a memory only. Persist, it stores the data in memory, disk, or both based upon the storage level you choose. Like we all have understood, we all have read this in our lower classes also, that in a computer we have a cache memory, and whenever we use like we know that cache memory can be used to help us in faster execution, right? So it is the same concept applies in Apache Spark as well. So the cache stores the data in a memory, and persist can store data in a memory, disk, or both based upon the storage level you choose. So here I've tried to compare both cache and persist method with the help of one table. The storage, memory only. The storage can be memory, disk, or both. Flexibility, we can't configure that, but we can set storage level. We'll discuss today in upcoming slides that what are different methods available. I'll also be showing you a little piece of code as well, some implementation as well, that how to use cache and persist in PySpark. Use case, it can be used when we have a small or a medium data that can easily fits in your random access memory. And if we use persist method when we have a large data which may not fit in memory, right? Speed, obviously very fast if memory is enough. It's slightly slower, safer for big data. Obviously we know that when we make use of RAM, we say that if we use it, we have a faster speed. When we talk about a disk, right, we say that it's slower to access. So same concepts applies here as well. So when to use what? Data is reused many times. You can use any cache or persist. Data fits in memory, use cache. Data is large, use persist. Data use only once, don't use cache or persist. Actually, the thing is, the cache or persist comes in those scenarios when you are reusing the things again and again, or when we have a very bulk load available. But if a data is only used once, okay, it's we don't have much of the we can say dependency, or we don't have much of the work or much of the transformations, right? Then you don't go for it, right? So let's see now what are different storage level options available, which I've already discussed in the tabular section also, that it is configurable, means we can configure multiple levels of persist. Let's see. The very first level is memory only. As the name suggests, it's the default for cache also, because cache by default stored in memory. So it's a default for cache also and available with the persist. This is a function we have to call. This is how we're gonna use it. Storage level dot memory only. Second one is memory and disk. As the name suggests, here the Spark stores the data in memory first. If there is no enough memory available, it spills to the disk if a memory fills up. It means if we don't have the much of memory available, the rest of the data goes to the disk, right? Third is memory only SER. SER stand for serialization. Serialization and deserialization are 2 points available. Serialization meaning is converting the data into the Java objects. Okay, so converting the Java objects into a byte stream. Okay, and deserialized meaning is converting that byte stream back to Java objects. So using persist storage level dot memory only SER, the Spark as serialize the data as bytes and stored in memory. So what's the benefit of converting into serialized way? Because serialization is very much important, because like we get two benefits. First, there will be it's good for the data storage, because when you convert the Java object into the byte stream, right, it will be easy to store the bytes, or the bytes the stream of bytes can easily be stored in a storage in any of the database maybe, right? It's very easy to store. And when you transfer the data over the network, okay, and if you have a serialized data, means if you have a byte stream available, we can easily send the data over the network. It not be consuming, or it not be having a burden on our bandwidth. So it's good to have the serialized option when you convert the Java object back to Java object into the byte stream. Next is memory and disk SER. With persist storage level dot memory and disk SER, the Spark serialize data and store it in the memory, spilling to disk if needed. Means the same concept. Memory and disk means first go to the memory, then go to the disk. But the only difference is we have a serialized thing available. Disk only, as the name suggests, the Spark stores only on a disk as deserialized object. Deserialize is opposite. Okay, deserialize meaning is converting the byte stream back to Java objects. Memory only, memory only too. With persist, the Spark stores data in a memory with 2 replicas across the cluster. So in this case, we have a backup option available as well, because we talk about the 2 replicas. Memory and disk too. Using persist storage level dot memory and disk 2, Spark stores data in memory and disk with 2 replicas. So in this case, we have a memory and disk 2, meaning is we have a replica available, the backup option available. So I hope it is okay, all clear. So let's now go with the implementation part, okay, in which we talk about the how we can simulate the same thing in the PySpark. Before we jump into that, let's now compare all the things together. Memory only, it's stored in RAM. Serialized, I'm again repeating, serialization meaning is converting the object into the byte stream. Although I've took the example of Java, but here I'm just talking about simple object. So the converting object into byte stream, it's called serialization. Converting the byte stream back to object, it's a deserialization. Actually, we use it in Java also. That's why I've took the example of Java. Backup copies, no, there's no backup available. When to use fastest small data that fits into memory, memory and disk, as the name suggests. RAM plus disk, serialized, no. Backup copy, no. Data might not fit in RAM, that's why we go with memory and disk. Memory only SER means, as the name suggests, RAM. Serialized, yes. Backup copies, no. Saves memory using serialization, because that's I've already said. Because the benefit of converting the object into byte stream is that it can easily be stored in a storage, okay, in a database, or it can also have a good impact on the network as well when you transfer data over the network. Memory and disk SER, RAM plus disk, yes, it is serialized as the name suggests. Backup copy, no. Large data, or it's compressed. Why compressed? Because we have already done the serialization part. Disk only is on disk. We know it's a slow. The accessing data from disk is slower. It's low memory. Serialized, yes, and this backup copy, no. Memory only 2, it is no. RAM, stored in RAM, right, and it's for fault tolerance because we have one extra copy available. Memory and disk 2 meaning is yes, extra copy available, fault tolerance for large data. So this is how we can compare all the persist options that we have. Okay, now let's go to the PySpark and let's see how we can take some basic example of this cache and how to make use of cache and how to use the persist method. So in this case, I'll be taking very simple example of RDD only that we already did in our previous videos, and let's see how we can apply that. First of all, let's create one basic data here. I'm using a basic data as 1, 2, 3, 4, 5, and now I'm going to create RDD out of it. RDD equal to sc.parallelize, right, and we're gonna use this data as a collection. It will create a RDD for me. Now let's apply very basic transformation. Okay, I'm using here RDD dot map. Okay, then I'm using lambda function. I've already explained this in the last video also. So here I'm just going to maybe square each number. For that I'm just using this basic transformation. Okay, so one transformation has been done. Now let's cache the result, means let's store in a memory. How we can do it? I'm gonna use this one RDD1 dot cache. That's it, very simple. That dot cache. So you can see we got some output here, although it not make any impact on the output. Output remains same. It's just for the performance, right? So now let's call the action here. Okay, I'm gonna use action. So I'm using this RDD1 dot count. RDD1 dot count. So in this case, I should get the result. Now the first action, this action, what it do? It triggers the computation and caching. Do the both things. it trigger the computation also and do the caching also. So it do the two things. So that's the reason you can see it will take some time. But when you do the second action, let's suppose if we go with the collect, let's suppose it will be using a cache data, which will be faster. So I'm again repeating. First we call the cache method. So cache method will store the result in a memory. So this one rdd1.count, what is happening here in this case? It's the first action which is triggering the computation and caching both. Now if we do this again, rdd1 dot, let's suppose collect, okay, you can see we get this answer immediately. This is only because of the fact that it's using a cache data, which is faster to access. Okay, now let's go with the persist also. How to use persist? For that we have to import one package from PySpark. Import storage level we are using here. Okay, now let's do make use of this again, rdd1 dot persist. This is how we're gonna use persist. Okay, here we can specify any storage level. How? We have seen in the PPT also. It is storage level, L capital, storage level dot, and let's suppose I'm using, okay, one more thing I want to say. This command may not work. Why? Because we have to first unpersist it. We have to use the unpersist option, because at a one time only one storage level can be there. Okay, now the storage level is what? Cache. Cache meaning is memory only. If we try to, let's suppose, change the storage level, let's suppose to memory and disk, it will not work, because the Spark will say I can't change the level, right? For that we have to use unpersist. This we have to use. Okay, this is important. Now we can apply any method here. Okay, I'm using here again rdd1 dot persist. Okay, rdd1 dot persist. Then we can use any storage level as you can use as per the requirement. Storage level dot memory and disk. This we're gonna use. Okay, now what we have done is, now we have converted the storage level from memory only to memory and disk. Okay, now let's do the simple count here. Okay, I'm using again rdd1 dot simple count. Okay, action we are performing. Again, it will take some time. Okay, this is just a like demo. I'm just calling an action here. Now before that we just use the persist method to change the levels, the storage level from the memory to memory and disk. Now we are using a simple count, rdd1 dot count. It should give me the count, whatever the count we are having, 5, right? Again, I'll again call another action just to show you. Collect again. Okay, collect. So I got the answer immediately. So this is what this video is all about, that this cache and persist will not change your output. Okay, the output will remain same. It's all about the performance, how we can improve your performance. Like it's based upon your like your requirement. If you have not have a bigger data, not if you have enough memory available, you can use memory only. But if you have bigger memory available, you have big data available, then you can use memory and disk, right? So I hope from this video you come to know that what is cache and persist and how to use it in the PySpark. Thanks for watching, guys. See you in next video.